Welcome to The Industrial Edge, the podcast where innovation meets precision. Hello, everyone, and welcome. I'm Jen Mesa.
And I'm Brad Jens. Today, we're really diving into something critical for industrial businesses. It's about choosing the right computing systems for specialized equipment. A big decision.
Yeah, it really is. And this deep dive, it isn't just for the tech experts, it's for anyone who's involved in making these long-term investment decisions in industrial tech. We want to help you avoid some of those, costly mistakes that can really derail things.
Okay, so let's unpack this a bit. It seems pretty common, right, for businesses to just reach for general-purpose computers first, the ones they know.
Exactly. It feels familiar. But our sources are pretty clear there's a significant risk there, one that often gets underestimated.
A risk? How so?
Well, the thing with general-purpose computers, their strength is also their weakness in industry. They're versatile, sure, designed for offices, quick changes.
Right, like standard Windows or Mac systems.
Yeah.
Precisely. But that design is sort of fundamentally at odds with what industry needs. Longevity, stability, operating in tough conditions, and that mismatch. It's why industry research shows something like 67% of projects that start with general-purpose systems hit major snags moving from development into actual production.
Wow, 67%. That's huge.
It is. Often means complete system redesigns, much longer project timelines. Big headaches.
So these general purpose systems, they've got that broad compatibility, consumer parts, maybe a 3 to 5 year life, typical office stuff.
Yep.
So then what makes an embedded system so different? How is it built for these specific industrial challenges?
Okay. Embedded systems are, specialized. They're purpose-built right from the start for specific tasks. The hardware is optimized for the job and crucially for the environment. Think factories, outdoor installations.
Much tougher conditions.
Much tougher. And they usually run custom or hardened operating systems focused purely on stability and predictability. No surprise updates, crashing the line. And the life cycle, this is key. We're talking 10, maybe 15 years. Plus, they're built for environmental hardening.
What does that mean exactly? Hardening?
It means handling extreme temperatures, say minus 40 Celsius up to 85 C. It means handling vibration, dust, electromagnetic interference, things that would kill a standard PC quickly.
Okay.
It's really about systems meticulously crafted for reliability, for consistency when it absolutely has to work, mission critical stuff.
Right. So theory is one thing, but let's talk real world. What actually happens when those less robust general purpose systems meet a tough industrial setting? What are the tangible consequences?
Well, the environment hits them hard. That narrow temperature range, maybe 0 to 35 C for a standard PC, it's just not enough. They're vulnerable to dust, moisture, constant vibration, things you find everywhere in industrial sites. And they aren't really designed for running 24/7 month after month.
Which is standard in industry.
Exactly. Compare that to an industrial embedded system built for that 40 to 85 C range, meaning vibration standards like IEC 6.0 strong EMI immunity. It's night and day. But it's not just the physical environment. The problems often go deeper into managing these systems long term.
Okay, so that leads us into lifecycle management. Beyond just, will it survive the heat or the shaking? What are the longer-term operational challenges, the hidden costs?
Well, think about those OS updates on general-purpose systems. They're frequent, often unpredictable. In an office, maybe annoying. On a production line, it can cause real disruption.
Unplanned downtime.
Precisely. Then there's component obsolescence. Parts in consumer-grade PCs might be unavailable after just 2 or 3 years. So if something fails, you might be forced into an expensive upgrade or redesign because you just can't get the replacement part.
Ouch. No long-term availability guarantees.
Right. We looked at a specific U.S. case study, a big automotive manufacturer. They put in 200 general-purpose PCs for assembly line monitoring. Within 18 months, nearly a quarter of them, 23%, needed replacing just due to environmental failure.
Yeah.
Dust, heat, vibration.
Wow.
And worse, software update conflicts caused 6 unplanned production stops. Imagine the cost of that.
Huge.
Yeah. And migrating the whole thing over to proper embedded solutions. It took them 8 months. Significant disruption, totally unbudgeted costs.
So it really makes you ask, what's the true cost here beyond just the initial price tag of the computer?
That's the critical question, the total cost of ownership.
That case study really hits home. So turning this around, what does this mean for long-term success? How do these purpose-built embedded systems give you a competitive edge?
Well, the long-term benefits are pretty compelling. Sources point to things like a 90% reduction in unplanned maintenance. That's massive.
90%.
Yeah, plus you get predictable update and maintenance schedules because of that long 10, 15-year operational lifecycle. You can plan properly.
And performance?
They excel where it matters, in industry real-time processing. Think millisecond critical tasks, like safety systems reacting instantly, or precise motion control for robotics. General-purpose systems often struggle there.
So it's about aligning the technology specifically with the industrial purpose.
Exactly, and that alignment gives you a strategic advantage, especially looking forward.
Okay, so future-proofing. How does making the right choice today set a business up for what's coming next in industrial tech?
Well, think about the big trends. Edge AI and machine learning are booming, right?
Yeah.
Doing complex processing right there on the factory floor, not sending everything to the cloud.
Requires specialized processing power locally.
It does. Embedded systems, often with specialized processors like GPUs or NPUs, and low latency performance, they're basically essential for making real-time edge AI work effectively. Then you've got 5G industrial IoT demanding robust, reliable edge devices, digital twin integrations needing constant real-time data feeds, and even sustainability goals. Embedded systems often consume less power and last much longer, reducing e-waste. It all points towards purpose-built, reliable, long-life systems.
So not just solving today's problems, but enabling tomorrow's innovation.
Precisely. The long-term strategic edge comes from that alignment, embracing these future capabilities that really depend on having the right foundation.
It seems pretty clear then. Choosing between embedded and general purpose, it's not just a tech choice, is it? It's a fundamental business decision.
Absolutely. It has long-lasting impacts on your operational efficiency, your costs, your ability to compete, and your ability to innovate down the line.
So investing that time up front, really analyzing the requirements thoroughly, that seems crucial for long-term success, not just grabbing what seems easy initially.
Couldn't agree more. That initial analysis pays dividends for years.
Well, this has been incredibly insightful. It really highlights how a seemingly small tech decision can have such massive ripple effects.
It's often the foundational choices that matter most.
We'll be back soon with more innovation, expert perspectives, and game-changing technologies powering the next industrial revolution. Until then, stay connected with Contec.